Have you ever been in a grocery store staring at two different sizes of the same thing and trying to figure out which one is actually the better deal? Well, it turns out the answer to that little puzzle is all about a super powerful math concept: ratio and proportion. And today, we're going to break down how this is the secret tool you can use to make smarter decisions every single day. Okay, so here's our game plan. We'll kick things off with why this stuff is so useful in the first place. Then we'll get into the basic ideas of ratio and proportion. After that, we're going to tackle two big types of problems: direct and inverse proportion. And finally, we'll see how it all comes together as a real-world tool for you. So, first up, why should you even care about this? Well, because whether you realize it or not, you are already using ratios and proportions all the time. I mean, this is a perfect example from our source material. You might just glance at it and think, hey, 50 is less than 110, so the smaller bag is cheaper. But is it a better value? Think about it. If you bought two of the 50-gram bags, you'd get 100 grams for just 100 TL. That's a 10 TL savings. And just like that, you've used ratio and proportion right there in the snack aisle. And this isn't just about pistachios, right? It's literally everywhere. Need to double a recipe? That's a direct proportion. Trying to figure out how long a road trip's going to take based on your speed? That's all about ratios. It's one of those fundamental things we use to make sense of the world around us. All right, so to really get good at this, we've got to build a solid foundation. Let's get super clear on what ratio and proportion actually mean. A ratio is just a way of comparing two numbers. That's it. It's that simple. It tells you how much of one thing you have compared to another thing. And this right here shows us the formal textbook definition. It defines oran, which is Turkish for ratio, as a comparison of two quantities of the same kind. You know, like comparing the weight of two apples or the length of two different ropes. Now check this out, because this is a really crucial first step. If you want to compare 30 centimeters to 4 meters, you can't just write 30 over 4. They have to be in the same unit first. So we turn those 4 meters into 400 centimeters. Now we can compare them. The ratio is 30 to 400, which simplifies down to 3 over 40. Okay, so if a ratio is a comparison, a proportion just takes that one step further. A proportion is basically an equation that says two ratios are equal to each other. And this is the classic setup you're going to see all the time. If the ratio of A to B is the exact same as the ratio of C to D, well, you've got a proportion. And this one idea is the key to solving a whole universe of problems. All right, let's jump into our first type of problem. This is probably the one we use most often: direct proportion. It's pretty intuitive. It's just when two things increase or decrease together at the same rate. The textbook calls this doğru orantı, and you can see it right there in the graph. It's a perfect straight line. More of X means more of Y. You double the input, you double the output. The key thing to remember is that their ratio, Y divided by X, is always the same. It's constant. Okay, let's put this to the test. Here's a classic problem. It makes sense that if you have more workers, you should be able to pave more asphalt, right? That's a textbook case of direct proportion. So how do we figure it out? And here we see the textbook's approach. It sets up the relationship between the number of workers and the area they can cover. Let's break down the logic behind it. So here's the most important part. The ratio of workers to the area they pave has to be constant. That means the ratio for 3 workers is going to be equal to the ratio for 7 workers. We set up our proportion. 3 over 108 equals 7 over X. From there, we just cross-multiply to solve for X. And there you have it. 7 workers can pave 252 square meters of asphalt in a day. The logic holds up perfectly. But not everything in the world works that way. Sometimes, when one thing goes up, another thing goes down. And that brings us to the flip side: inverse proportion. In the textbook, this is called ters oranti. And notice the graph. It's not a straight line anymore. It's a curve. The key here isn't a constant ratio. It's a constant product. X times Y always equals the same number. That's the big change. Okay, let's think through this one. If you have fewer workers, is the job going to take more time or less time? More time, obviously. One number goes down, the other goes up. That's our big clue that we're dealing with an inverse proportion problem. And once again, let's turn to the textbook to see the official setup for solving this kind of problem. It looks a little different than the last one, and for a really good reason. So here's the mental shift. We're not using equal ratios anymore. We're using that constant product. The total amount of work hours to paint that wall
is a fixed number. So 6 workers times 15 hours has to be equal to 2 workers times X hours. All we have to do is solve that simple equation.
And the answer is 45 hours. It makes perfect sense when you think about it. 1/3 of the workers is going to take 3 times as long. Okay, let's just pause for a second because this slide is the whole shebang. It puts everything side by side. For direct proportion, values move together, the ratio is constant, and you solve by cross-multiplying. For inverse proportion, values move in opposite directions, the product is constant, and you solve by multiplying straight across. Figuring out which situation you're in, that's the entire game right there. And just like that, you've unlocked this incredibly powerful new way of looking at problems, not just in a math class, but out there in the real world. So the next time you're adjusting a recipe, planning a road trip, or trying to figure out the best deal on pistachios, remember what we talked about here. You can use direct and inverse proportion to go from just guessing to actually knowing. So I'll leave you with this one final thought. Just look around you this week. At your job, at home, in the store, what's one problem or decision you have to make where you could apply this logic of ratio and proportion to get a much clearer answer? I bet the more you look for it, the more you'll see it.